Okay, one thing that can make verifying identities frustrating is that you may choose a method to utilize, and then you start working your way through it, and you're not getting anywhere. All right, so that's gonna test your frustration tolerance. Okay, you might not choose the right method. All right, or it may be an okay method, but maybe you just can't see it through till the end. All right, so if something's not working, you always got to keep in mind, go back, start from scratch, try something different. All right, and try to control your frustration. All right, that's just part of the process, part of the problem solving process. Uh, so don't get discouraged. Stay positive. All right. So as we look at this one, we talked about typically working with the side that's a binomial over the side that's a monomial. All right, and that's valid. All right. So one possible option here is to maybe rewrite the secant as 1 over cosine and rewrite the tangent as the sine over the cosine. All right. That could be something that we may want to do. All right. So you could try that, and it may work, it may not. But I want to do something a little bit different. I want to work with the right side and do a different procedure. And that procedure is one that we visited at the end of 7.1, which was multiplying by the conjugate. All right. So if we multiply both sides by the conjugate of what we have in the denominator, the conjugate of 1 minus sine y is 1 plus sine y. Okay? And when we do that, in our numerator, we will now have cosine y and 1 plus sine y. All right? And in the denominator, we can actually go ahead and multiply that conjugate pair to give us 1 minus sine squared y. Remember, conjugate pairs are, you don't have to multiply the first and the last term. Okay? So, what do we see now in the denominator? Yeah, with this denominator, we can apply our primary Pythagorean identity, sine squared plus cosine squared equals 1. If we rearrange that and move the sine squared over, 1 minus sine squared y is equivalent to cosine squared y. Okay. Now, what you should notice there is we have a cosine y in the numerator and a cosine squared y in the denominator. So that's just like having x over x squared, right? That can be simplified. So this cosine y will drop out, right? And the cosine squared will become just cosine. So we'll have 1 plus sine y over cosine y. If we look at what we need to achieve, it's secant y plus tangent y. All right. We don't have a secant or a tangent in our expression at this point, or on that right side. But we can get there, right? Remember that if we have a monomial in the denominator, we can apply that division to every part of our numerator. So this would become 1 over cosine y plus sine y over cosine y. And that's where the magic happens. Well, that's 1 over cosine y. Secant. And what's sine over cosine? Tangent. Which is exactly what we need. So that